So in 31, find the present value of 40,000 due in 4 years at an interest rate of 6% per year compounded daily. So we use the same formula. Here we have P equals A 1 plus R over N to the negative NT. So we put in the 40,000, 1 plus the R is 0.06, N is going to be daily, so it's 365 to the power negative 365, and we have 4 years. So we're going to simplify it. We have 40,000, 1 plus 0.06 divided by 365, the power negative 365 times 4. Then we have 32. So it says, how much money should Jack deposit in a bank paying interest at the rate of 6% per year compounded continuously, so that at the end of 3 years, the accumulated amount will be 20,000. So that's going to follow A equals PE to the RT. And then if you solve for P, we end up with A over E to the RT, which is AE to the negative RT. The future value is going to be 20,000. E and then negative R, which is 0.06, and then T is going to be 3 years. And then you have E negative 0.06 times 3. So that will give us 16705.40. Find the interest rate needed for an investment of 5,000 to grow to an amount of 7,500 in 3 years if interest is compounded quarterly. So it's compounded quarterly, so that means we're going to use A equals P 1 plus R over N to the NT. So P, that is going to be 5,000, 1 plus R, that is what we're looking for. Quarterly means N is 4, and then T is 3 years. The future value, so that is given, that's 7,500. So if you divide by 5,000, we got 7,500 over 5,000 equals 1 plus R over 4 to the power 12. So this will simplify. 75 over 50. That is going to be 1.5. So how can we get rid of this 12? Well, we take 1.5 and then we're going to take it to the 1 over 12 on both sides. So we have 1 plus R over 4. So this is to the 12, and then we take it to the 1 over 12. So that will leave us with 1.5 to the 1 over 12, and then you subtract 1. That will equal to R over 4. So R is going to be 4 times 1.5 to the 1 over 12 minus 1. Four times 1.5 to the 1 over 12 minus 1. That will give us 0.1374. So we got an interest rate of 13.13. 0.75%. How long will it take 5,000 to grow to 6,500 if the investment earns interest at the rate of 6% compounded monthly? So here we have how long will it take. That means we're solving for t. Here we have a equals p1 plus r over n to the nt. And here we got 6,500 equals p, which is 5,000, 1 plus r, which is 0.06 monthly. So that's 12, and then t. So we got 6,500 divided by 5,000. 0.06 divided by 12, that's going to be 1.005 to the 12t. So next step is you got 1.3, and then we're going to get the natural log on both sides. We got ln both sides. Then we're going to move this 12t to the front. So we have ln 1.3 equals 1.2t, or 12t. ln 1.005. So t is going to be ln 1.3 divided by 12 ln 1.005. Then you can get a approximate. And we got 4.38. Next question, 35. So the total cost incurred in operating a certain type of truck on a 500-mile trip traveling at an average speed of v miles per hour is estimated to be C of v equals 125 plus v plus 4,500 divided by v dollars. Using differentials, find the approximate change in the total operating cost when the average speed is increased from 55 miles per hour to 58 miles per hour. So the general differential equation is going to be dy equals f prime of x dx. This is the general differential formula. So in this case, we have the letters capital C, we have a v, so we're going to use dc equals c prime of v dv. Then we can get c prime of v, so that's going to be a 1. And then this can be written as v to the negative 1, so we end up with a negative 4,500 v to the negative 2. And then dv, that's going to be the difference between 58 and 55. So we can plug that in. We have 1 minus, this is 4,500 divided by, and then we plug in the initial value. This is the initial speed, 55 miles per hour. And then the dv, that is going to be 58 minus 55. So we have the final minus the initial speed. So putting it into the calculator, we end up with negative 1.46 look back in the question. So here it's asking for the approximate change in the total operating cost. So that means if you increase the speed from 55 to 58, there's going to be a decrease of $1.46 in the operating cost. We have some more application questions. So number 36, the relationship between the amount of money X spent by Canon Precision Instruments on advertising and Canon's total sales S of X is given by the function S of X equals negative 0.002x cubed plus 0.6x squared plus x plus 500, where x is measured in thousands of dollars. Use differentials to estimate the change in Canon's total sales if advertising expenditures are increased from 100,000 to 105,000. So here we're going to use differentials. ds equals s prime of x dx. Here we have ds, and then the derivative, that's going to be negative 0.00, or 0.006 x squared plus 1.2x plus 1. And we multiply that by dx. So we have ds equals, and then we're going to plug in the initial. So the initial value is 100. And then dx, that's going to be 105 minus 100. So we plug in and we simplify it. So times 100 squared plus 1.2 times 100 plus 1. And then we multiply by 5. That gives us 305. So what does that mean? It means that we have an increase in the total sales. Increase of 305,000. So in question 37, the total weekly cost in dollars incurred by Lincoln Records in pressing X compact discs is C of X equals 2,000 plus 2x minus 0.00001 x squared. What is the actual cost incurred in producing the 1,000 first disc and the 2,000 first disc? So part A, we're going to get C of 1001 minus C of 1000. So that will look like 2000 plus 2 times 1001 minus 0.00001, 1001 squared, and then minus, in parentheses, 2000 plus 2 times 1000 minus 0.00001, 1000 squared equals, plug into your calculator, okay, and then we put a minus sign and then parentheses, 2000 plus 2000 minus 0.00001 times 1000 squared. That will give us 1.98. So if you round it up, we'll get 1.98. Then in part B, we do the same thing. We got C of, in this case, it's going to be 2001 minus C of 2,000. So here we're going to end up with 1.96 in the end. So part C, here we want to, or sorry, this is still part B. What is the marginal cost? So for the marginal cost, we're going to get the derivative. C prime of x equals 2 minus 0.00002x. So if we plug in 1,000, we end up with 1.98. And then if we plug in 2,000, 2 minus 0.00002 times 2,000, then we end up with 1.96. Letter C is to find average cost function. So we need to take C bar of x equals C of x divided by x. So if we divide by x, then we got 2,000 over x plus 2 minus 0.00001x. And then letter D is to find the marginal average cost function. So we take C bar, get the derivative. That's going to end up being negative 2,000 over x squared. Derivative of 2 is 0, and then we have minus 0.00001. So in question 38, it says to find the average cost function, find the marginal average cost function, and what happens to C bar when x is very large, and interpret your results. So first is to find the average cost function. That's going to be C bar of x equals, and then we take 100x plus 200,000, all divided by x. So that simplifies to 100 plus 200,000 divided by x. Then in part B, it says to find the marginal average cost function, C bar prime of x. So that will equal to negative 200,000 divided by x squared. Then in part C, it says what happens to C bar of x when x is very large. So as you can see, if you get the limit as x approaches infinity of 100 plus 200,000 over x, that's going to be equal to 100. So what does it mean? Well, it means that as production increases to a high level, the average cost to produce the item, so in this case it's a desk, is going to be $100. So in question 39, Williams Commuter Air Service realizes a monthly revenue of R of x equals 8,000x minus 100x squared dollars when the price charged per passenger is x dollars. Find the marginal revenue R prime. So R prime of x equals, here it's going to be 8,000 minus 200x. Then in part B, compute R prime of 39, 40, and 41. So we can plug in the values. R prime of 39, 40, R prime of 41. So it's going to be 8,000 minus 200 times 39, 8,000 minus 200 times 40, 8,000 minus 200 times 41. So we got those values. It's going to be in dollars. So here it's going to be $200. Then we have 8,000 minus 200 times 40, so that is going to be 0. And here we have 8,000 minus 8,200, so it's a negative 200. So part B is, or part C is based on the results of part B. What price should the airline charge in order to maximize their profit? So remember the R prime, that represents the change in the revenue. So in this case, we want no change in the revenue to maximize the revenue. So to maximize the revenue, we're going to select X equals 40. So that is the price for the charge of the air service. So the airline should charge $40. Question 40. Here it says that the weekly demand for the Pulsar 25 color LED television is P equals 600 minus 0.5x, where P denotes the wholesale unit price in dollars and X denotes the quantity demanded. The weekly total cost function associated with manufacturing the Pulsar 25 is given by C of X equals 0.000002x cubed minus 0.03x squared plus 400x plus 80,000, where C of X denotes the total cost incurred in producing X sets. Part A, find the revenue function R and the profit function P. Okay, so for part A, the revenue function R of X, that is going to be the price times X. So Px equals 600 minus 0.05x times X. So R of X is going to be 600x minus 0.05x squared. Profit function P, so P of X is going to be R of X minus C of X. So R of X, that is this one over here, and then minus C of X. So if you simplify already, here we're going to get 200x, and we'll get a minus 0.02x squared, a minus 0.000002x cubed, and then a minus 80,000. So that's part A, and then part B is to find the marginal cost function. That's going to be C prime of X. So we already have the function. We're going to get the derivative. So we have 5 zeros and then a 6x squared minus 0.06x plus 400. And part C is to find the revenue function. That's R prime of x. So we've found the revenue that was over here. Get the derivative is 600 minus 0.1x. And then d is the marginal profit function. So p prime of x equals 200 minus 0.04x minus 0.000006x squared. And then e is to do some computations. So c prime of 2000 so we just plug into the calculator. Minus 0.06 times 2000 plus 400. Here we got 304. And then r prime of 2000. I think we can write on a separate piece of paper. So we found c prime of 2000 is going to be 304. R prime of 2000, that's 600 minus 0.1 times 2000. So that is going to be 600 minus 200, which is 400. And then we also have p prime of 2000. So that is going to be 200 minus 0.04 times 2000 minus 0.00006 times 2000 squared. That is going to be 96. Interpret your results. So here, the cost to produce, so we add 1 to the 2000, so it's going to be to 2000. And first, here the item is going to be the LED television, $304. The revenue made on 2001 television is going to be 400. So the profit made on 2001 television is going to be $96. Then letter F is to find average cost function c bar of x. That's going to be c of x divided by x. So that's given. We have c bar of x equals 0.000002 x squared minus 0.03x plus 400 plus 80,000 divided by x. G is to find the marginal average cost function, c bar prime of x. So we get the derivative, that's going to be 0.000004x minus 0.03. Derivative of 400 is 0. And then here we move it to -1 to get negative 80,000 over x squared. So thanks for watching. I hope that helped you to study for the Business Calculus chapters 1 and 2. Thanks for watching, and don't forget to subscribe if you're interested in more math tutorials.